Hey everybody, I'm Zach Manchester. I'm an assistant professor in the Robotics Institute at Carnegie Mellon, and we're gonna have a little discussion today about kind of the whys, whats, and hows of grad school and how to apply and why you might want to apply and sort of what your grad school experience may be like. And also here, do we want to just go around and everybody say a quick hi and introduce themselves?
Sure. Hi everyone. My name is Jaskaran, and I'm a first year MRSD student. And yep.
Hi, I'm Michelle. I'm a fourth year PhD student. I work on human robot interaction.
All right. All right, so let's get into it then. Okay, so quick overview of what we're going to do. So first, I'll talk a little bit about why you might want to go to grad school and particular differences between, say, PhD programs and master's programs. Then we'll have a discussion of the application process and things to think about. Then kind of day in the life from a couple of current grad students at CMU and kind of what their day-to-day is like. And then we'll have an extended kind of Q&A session where people can submit questions and we'll answer them for the kind of the whole second half. All right. So first, I'll talk a bit about like why you might want to go to grad school, what that's all about, and sort of the pros and cons and differences between PhDs and master's programs. So first, yeah, that whole master's versus PhD thing. So master's degrees, there are lots of different programs, and there's lots actually just at CMU that we could talk about. These are typically self-funded, meaning you pay tuition just like in undergrad. They range, but the average is sort of, year and a half to 2 years. And the last point there is that they're typically, the admissions rates are typically higher. They're typically like easier to get into than PhD programs. There's more spots, that kind of thing. And then within master's degrees, there's sort of two categories. There are professional master's degrees. Often these are called MEng degrees. And these are intended for people who want to go into industry. So they're mostly class-based. You'll take a whole bunch of courses, and then often they'll have some kind of capstone project or team or group project involved. And these are, sometimes called terminal master's degrees, course-based master's degrees, industry-focused degrees. But the idea at the end of the day is that you're going to do this coming out of undergrad. You would take another year or two of classes and kind of focus a little bit into get a little bit more specialized into some technical areas, and then work on kind of more project-focused stuff, and then go get a job in industry from there. In contrast, the kind of other master's track are these so-called research-based master's degrees. And what these are really kind of a pathway towards a PhD. So in this kind of master's program, you will definitely take some more classes, but you also will have to do a thesis. So you'll have to do some research, spend some time in a lab, and sort of do enough new stuff in that research setting to kind of to put together a thesis document. And again, the intent there is that you learn how to do research. You also learn some new technical skills, but it's pushing you down a path towards further grad school and kind of queuing you up to be able to apply to PhD programs. Often this is a good idea if you're trying to pivot from your undergrad degree into maybe a different direction for your PhD, switching fields, that kind of thing. This gives you an opportunity to get into a new area and then be sort of more competitive in PhD applications in that new area. Okay, PhDs. This is kind of, the other thing to talk about. So these are really, as opposed to the master's degrees, these are very much about doing research, much more so than taking courses. You'll typically take courses for like the first year to 2 years of a PhD, but then after that, you're really doing research, working in the lab, publishing papers, all that kind of stuff, rather than taking a lot of courses. And again, it's all about research, creating new knowledge, right? Rather than studying courses at that point. We've expected, you're going deep in a certain area. You've taken all the classes there are to take in your chosen area of specialty, and now you're kind of doing new stuff. You'll also, as part of this, have opportunities to teach and mentor other students. So, in most places, our department included, you're required to TA twice, and that's kind of the standards. You're required to actually serve as a teaching assistant and help teach, learn how to teach. You'll also typically in less formal ways end up mentoring other students. It's pretty typical to have a PhD student kind of supervise one or two master's students or a team of undergrads on their research area and sort of have them kind of work on their project in the lab. And the intention of a PhD is to set you up for a research career. This could either be in academia, going on to become a professor or a research scientist, or in industry. And there are now actually quite a lot of industrial research jobs for people with PhDs at all the kind of places you would expect, all these big companies. But I think the average length for a PhD in the US is 5.5 years. So typically it takes 5 to 6 years. That's coming out of undergrad. It's sort of that 5 to 6 year range. And then typically in PhD programs, you will receive a stipend and you will not pay tuition. So basically you get paid to be a PhD student rather than you paying tuition, which is maybe the one major difference between a master's program and a PhD program. It's longer, but you're not paying tuition. You get paid to do it. All right. So here's sort of a typical timeline for a PhD. The first year, you're mostly taking courses. So you might take, like, again, here, something like 4 courses over the course of the year. So it'd be 2 per semester. And like, this is more or less the structure of our PhD program in the Robotics Institute. So you would take sort of a core course and an elective course fall and spring of your first year. And also, typically at this point, it depends on the department and how they do things, but it's pretty common to have some sort of rotation kind of thing, the first semester at least, where you can meet faculty, kind of get introduced to their labs and see a little bit, their research and try to figure out a good fit for you research-wise with a lab. So that's year 1. Year 2, again, here you're also taking courses, but you're really starting to get into research. So in our department, you might again take a core course and an elective course fall, spring. And then after that second year, you're pretty much done taking classes. That's it. And you're, again, in that second year, you really want to be kind of hitting your stride in a lab and really starting to do some research. Year 3, you might work as a TA. And typically you'll TA one of the courses you took, but that's not necessarily the case. And then in our department, we have what we call qualifiers. This varies a lot between departments, programs, schools. These are often called quals or qualifying exams. In our department, we have 3 different qualifiers: a research qualifier, a speaking qualifier, and a writing qualifier. And essentially, you have to more or less write a paper and give a public talk. This sort of thing is pretty standard. The exact format and requirements and whatever vary a lot, but most places will have some sort of qualifying exam in the kind of, end of the first year, sometime in the second year, that kind of thing. And then at this point, also kind of that third year, you're really digging into the research. And hopefully at this point, you're kind of getting a paper or 2 out in that year, going to a conference or 2, this kind of thing. In year 4, this is when you've really honed in on your research direction. You're on track to your dissertation. You have a topic, a well-defined scope for what you're going to work on. And at this point, in our department, you do what's called a thesis proposal. This is where you actually give a presentation to your committee. You form a PhD committee. So this is your advisor plus a handful of other people who are domain experts. It's pretty common. It's required in our department, a lot of other schools, to have an external committee member who can be from another university or can be from industry, from a company, who's again like a domain expert in the thing you're working on. And you prepare a talk and kind of lay out, here's what I've done so far. Here's my plan to finish up my dissertation. Here's the papers I'm going to write. Here's the work I need to do to get there, and kind of put that all together and kind of have your plan. And that kind of gets approved, and maybe there's some back and forth on this. And then you kind of go execute that plan for the next couple of years. And then hopefully in year 5, you're writing that dissertation, finishing everything up, publishing a journal paper or 2 to kind of wrap all that stuff up, and then doing a defense somewhere in that year 5, maybe into year 6 range. So that's what that looks like. And then finally, this is sort of this decision tree on, how to think about this and, what to do with your life, maybe. So do you enjoy academia? Yes or no? If not, maybe just apply for jobs and don't do this. If yes, there's sort of this question of, do you want to work in industry as an engineer, or do you want to, in more of a research lab setting where you're trying new things and trying to, kind of build new knowledge? And then sort of, so maybe on the industry side, there's, the sort of professional master's programs. These tend to be, though, expensive. They're basically just like undergrad. You're paying tuition for 2 years, that kind of thing. So there's definitely a question there about affordability. There are fellowship opportunities, maybe applying to those. Taking out loans can be a thing, right? And can you do that? If yes, cool. If not, maybe apply for jobs. And again, there's also a lot of arrangements where companies will fund employees' master's degrees. So that can be an option too. Then going back up the tree to the research side of thing, if you have done some research before in undergrad, which is pretty common, and it's a really good idea to get into that early if you're interested in this kind of stuff. So if yes, cool. Are you ready to spend 5 years of your life doing more of that? If yes, maybe a PhD makes sense. If not, think about the research-based master's programs that are a lot shorter, and maybe then reevaluate if you think you're still into the PhD thing. And then again, if you haven't done research before, or if you want to, or if you're thinking about maybe pivoting from one field to the other, from your undergrad to something you think you want to do in a PhD program, in either of those cases, it can be a really good idea to do a research-based master's. That will let you build some experience in a lab, maybe get on a paper, and also kind of really go deep in a new area and kind of prepare for applying to PhD programs and being a competitive applicant. Okay, I think that's it for me. And next up is more about how to apply to grad school and kind of some of the mechanics of that.
Cool. Yeah, let's talk about how to apply to grad school. So there are four major components of any grad school application. Those components are your CV or resume, the statement of purpose, letters of recommendation, and test scores and transcripts. So we'll talk about these sort of in more detail about each individual component. Next slide. Yeah, so your CV. Generally, at a high level, the goal of the CV should be to concisely convey your relevant skills and experience. So some information the CV should include would be research experience, any publications, abstracts, posters, workshop papers, or any presentations that you've done of your research. Any technical internships, whether sort of in research or in industry, should be there. Long-term projects. Fellowships and awards should be included. Any academic service, including volunteering, mentoring, TAing, should all be on the CV. It's probably not recommended to include shorter projects, like semester-long projects. So it's sort of optional. I think if you're applying maybe out of undergrad, it could be useful to include just like that. But you also don't need to include any personal information, like marital status, age, photo, citizenship. Some tips for your CV. They're typically longer and more detailed than a resume that you would perhaps hand out to companies. And you want to ensure that the formatting is clear, concise, and consistent. Any presentations or papers that you have, you should also include links to or paper websites. There's no real page limit for a CV, but it's a good idea to stick to about 2 to 3 pages. For the work that you've done on research projects or at technical internships, a good idea to write about the work that you completed, sort of the contributions that you made to those projects. And you can write those as a set of results-oriented bullet points. So it could be something like developed, implemented X for whatever reason for the task, achieving a certain set of results. So next, the second component is your statement of purpose. And the objective of the statement of purpose is to identify what you want to study and why. And so you have, since this is an essay, you have more space to elaborate on kind of your research and what research direction you want to go in than you have in kind of the information provided in your CV. So your SOP should include what problems are you interested in exploring? That's identifying your research area and motivation. Why are they important to you? Are you also interested in the societal impacts of that work? Also, you should discuss why are you qualified to tackle these problems, kind of how your prior experience has contributed to you having the skills, interests to tackle the problems that you want to tackle in grad school. So you should also include why this specific program is right for you. And so that can be talking about what professors you want to work with, what resources does the program have that would help you achieve your goals, and how this program will help you achieve those goals. So this is just like a university fit. And so a great SOP includes how has your experience shaped what you aspire to do? What are your shorter and longer term goals? So, what are you hoping to get out of grad school, and how is that going to translate to what you want to do in the future? Also, how do you plan to give back to the academic community? And so again, like you don't want to simply repeat what kind of a list of bullet points about, what you did previously, but you want to talk about how those past experiences have shaped kind of your thought processes, your interests. So really kind of talk about like what you learned from those experiences as well. And that is an opportunity that, your CV doesn't afford you the opportunity to invest much. So there are a lot of sample SOPs out there, and across lots of different subfields as well. So there are a lot of like computer science oriented SOPs, and a lot of great resources. And yeah, these are two potential links, but I'm sure there are many more.
All right. So moving on to another component of your application, which also, when I was applying, a lot of people told me is the most important. But that is mainly because this is the component that you don't really have a lot of control over. So you can write a very good resume, a very good SOP, and get the grades you want. That is pretty much in your hand. But I think having someone else attest to your capabilities speaks a lot during your applications. So the first thing is, who do you ask for a recommendation? A lot of times during applications, you would want to ask professors that you have done projects under or that you have taken classes. The most strong recommendations, I think, come from professors who you have worked with at least for a year or 3 semesters. If you have work experience, then probably someone in your work environment. Some universities, I remember, also require you to submit a recommendation from your thesis advisor. So if you're like a fresh undergrad and still doing your thesis, it might be a good idea to talk to your thesis supervisor. And it is not recommended to take recommendations from professor who you just took a class with, because they probably didn't get much time to interact with you one-on-one. And the same goes for employers that you didn't work very closely with, so they can't really attest to you as a candidate. Now, the person you ask to write your recommendation, either your manager or a professor, is probably a very busy person and they don't remember everything about you. So it's good to give them something that can help them remember you or remind them of your work, some good things that you did during your experience with them. So the first step is obviously to choose your recommenders and choose them wisely, because you might get a fixed number of recommendations, and then you reach out to them soon. You don't reach out to them 2 days before your deadline. You reach out to them soon. You push on 1 or 2 reminders a couple of weeks before the deadline, and then you also give them some things to remind. For example, you tell them what you worked with them on, what were your contributions, what you learned during your experience with them, did you publish or not, and those kind of things. Okay, the next thing, which is not a part of your wouldn't be a big part of your decision process, but is important as a grad student, or especially as an international grad student, is fellowships. So there are a lot of fellowships out there which you need to apply to early, and that's why it's a good idea to start early. So we have classified them into three parts here: fellowships for US citizens, for non-US citizens, and just fellowships without any citizenship requirements. Um, I won't go into each fellowship specifically, but the general thing is that there are some fellowships by governments, there are some fellowships by, for example, not-for-profit agencies, and some by just companies. So it's good to start early, make a note of these, and just apply. Don't really pinpoint and apply, just apply to as many as you can, and it really helps. And these are not just fellowships in the US, but also fellowships, maybe international fellowships. So if I want to talk about finding a program, I think to talk about finding a PhD program, maybe either Michelle or Zach, you want to take that one?
All right, cool. Thanks. So yeah, I think one thing that at a high level I'd really try to emphasize in terms of PhD admissions, it's really, really about fit with a particular lab and a particular professor. So you should probably think about this more like applying to a job, like you're applying into a particular lab to work for a particular professor, rather than like undergrad or even master's programs where you're applying to a school or a department and you're trying to like apply to the most top ranked program or whatever. It's really about the lab. Like that's where you're going to work. That's where you're going to spend all your time in that small group of people. And that's what really matters. And you really want to go find faculty and labs that are doing the stuff you're most interested in, that you want, who you want to work with, right? That's the thing that matters the most. So you want to identify those people at different schools. And really, again, you're looking for individual faculty members, not the department, the program, the school, whatever. And so find people whose work you're really into. You should try to understand their work and read a couple of their recent papers to kind of calibrate and know what they're doing to craft your statement. And again, yeah, you should say this in your statement. You should say like, I'm really interested in these things. Professor X and Y are like doing state-of-the-art stuff in this area that I'm really into, and here's why. And so you should have an informed, picture of what they're doing and be able to say something like that in your statement. And then should you reach out to professors? This is a contentious topic. I can speak personally, right? I get a ton of email. It's horrible. I get like, hundreds of emails a day, and it's horrible and hard to keep up with. A lot of people, I don't think it hurts you to email professors, to reach out. Frankly, the best thing to do is to actually try to meet people in person. And if you can afford it and you find a way, going to a conference is actually awesome. So if you're in robotics, right, ICRA and IROS, these kind of things are like the big conferences. If you can find your way to a conference and like try to meet people in person, talk to their students, this is the best thing. As far as reaching out by email, I think honestly, the most likely scenario is you're going to get ignored, just not get a response. It's not going to hurt you, but it may not help because it's hard to stand out when someone has 500 emails. It's likely you just won't get a response, right? So again, it won't hurt you, but it may not be the most effective thing. If you're gonna do it, I strongly suggest, again, doing your homework, understanding that person's research, read some papers, and have something to say that's informed. That's not just like for example, I get a lot of emails that's, in my case, like, I'm really interested in deep reinforcement learning, and here's why. And like, I don't work in that area, right? So getting an email like that, it's clear that they didn't read my website or know anything really about me, and they're just sort of blindly sending emails. So don't do that. That will definitely not get a response. But if you say something insightful and like it's clear that you like read my papers and stuff like that, I would pay attention and maybe respond to that. So I think that's kind of the main advice on that.
Application fee waiver. So it is definitely very expensive when you're applying to grad schools. It takes about $100 per university, and if you plan to apply to European schools, it's like $150. And it would definitely help if you are unable to afford the application fee and you want to apply to like 7 or 8 schools. So there are a lot of programs out there. If you have a financial need-based requirement that you want an application fee waiver, you should definitely apply to those. Or you could just email the admissions portal and they would definitely reply. Okay, I think now we're on to the most interesting part. What is grad school like?
Okay, I suppose I can say something about this.
Yeah.
So yeah, so in the US, we talked about how to, kind of like identify individual faculty members when you're applying and this sort of thing, but generally you're applying in the US for a program, i.e. PhD in robotics, and not necessarily to a specific project. And though there's a lot of variation in this, PhDs are typically funded. We said this already, right? Your tuition will be covered and you'll get a stipend, you get paid. It is common to come straight from undergrad into PhD programs in the US, though, not necessarily this, it can go either way. You can go straight from undergrad to a PhD program in the US. That's kind of normal. You can also do a master's first and then the PhD. So, and yeah, from undergrad, the average is 5 or 6 years. And then, yeah, I don't know, being American, this is sort of funny to me, but yeah, the US is big and, it varies a lot from one part of the country to the other, totally different climates, cities, transportation, need a car, not cost of living, culture. These all, the US is huge. And this is very, very different from like East Coast, West Coast, North, South. So that, I guess. And then this is for you guys, the PhD students, to actually talk about what you do on a day-to-day basis. So I'll let you guys take it from here.
Okay, I guess I'm up first. I think a day like for a master student is probably pretty well defined. And something that I recently was talking to a friend about was that PhDs and master student have kind of the same time at hand, but it just seems very less because you don't have control over your own time when you're taking classes and have assignments to submit. So that's a big difference. And I usually have classes in the morning up till the afternoon. So I get to campus and then I'm like in class after class, after which I have a TA, which I do after lunch, and that takes about an hour or two. And then I work on assignments because, yes, we get a lot of assignments. And I work on assignments till about dinner, after which I unwind and then chill and then call back home. And then very late in the night, I remember that I'm supposed to get an internship. And then I open up my laptop again and start working on that. And these are some cool pictures from my 2 months at CMU so far, and it has been very, very cool. Yeah.
Cool. So this is my day in the life. From 8 to 9, I'll get to campus, take on my morning ritual of grabbing coffee, check emails and respond to emails. From 9 to 11, I'll sort of just do research, reading, or technical implementation of things. 11 to 12, not all days, but some days I'll meet with my advisors. So I'm co-advised, so I have two advisors, and discuss research, discuss progress, any roadblocks. 12 to 1, I'll have lunch with my office mates, who are wonderful. And yeah, this is my office. From 1 to 3, just more research, more assorted work on my to-do list, which varies, every week. So sometimes it's writing, sometimes it's also meeting with undergrads and discussing their projects as well. Not all days, but some days, I'll have lab meetings from 3 to 4. If no lab meeting, I'll maybe take a boba or snack run, even just have hallway conversations. And hallway conversations are something I love about grad school, where you just bump into someone and suddenly you're just chatting in the hallways about something random, or, our lab meetings are great because we'll talk about our successes, our challenges, and it's especially nice hearing about people's challenges, because it's great to know that, everyone succeeds, everyone struggles, and, we're all in this together. From 5 to 7, I'll maybe debug code, or I don't know, yeah, debug code. And 7 to 8, I'll climb, run, or play tennis. So there's this cool climbing gym nearby called Ascend, good climbing. And from 8 to 10, make dinner and meal prep, and then watch TV and sleep.
And some cool pictures from the afternoon get-togethers that Michelle was talking about. So, yep, And this is RI at the conferences this year, ICRA, and then recently IROS in Michigan.
Yep. I should add, yeah, this is the fun part. This is kind of the reward for working hard and getting papers out, is getting to go to cool places. So ICRA was in London this year. I think next ICRA is in Japan. Like, you often get to go. The reward for working hard for 6 months or a year on something in the lab and getting a paper out is that you get to go have fun for a week and go to cool conferences. And we do have a lot of fun. And because RI is so big, there's always a huge CMU crowd at these things.
Yeah, there's also conferences like Grace Hopper and like SACNA's National Diversity and STEM conferences, and those are also a good place to go to talk to like representatives from grad schools, and you can like talk to the booths at those types of conferences and get fee waivers as well, just to note.
Cool. Okay, so a little shameless plug for CMU. Why CMU? I think a lot of what we talked about so far is pretty generic to grad school anywhere, but in particular CMU. So if you're into robotics, the Robotics Institute at CMU is kind of an awesome place. We're the biggest single robotics department anywhere. There's over 60 full-time faculty, over 500 students, and we're a robotics department. So at a lot of other places, robotics is kind of spread around. There's people doing robotics in mechanical engineering, computer science, EE, it's this kind of thing. And here it's under one roof. And it really makes it an awesome place to have collaborations across different areas. And I don't know, it's just a very cool and somewhat unique thing. And RI was the first PhD program in robotics. We're the original robotics place. In addition, there's also really strong industrial connections. There's lots of opportunities for working with companies on research projects and doing internships. There's also, obviously strong government connections. We do lots of work with NASA, for instance, in my lab, and various government agencies. And there's also very strong ties to all the other departments. We actually have a machine learning department here, but electrical, mechanical engineering, all these other areas. So for instance, I have, in addition to being full-time in RI, I have courtesy appointments in mechanical and electrical engineering and co-advise students across departments. So that's all very easy and transparent. And then on the sort of other side of things, like living generally, Pittsburgh is actually, as a major city in the US with like a tech scene, is one of the most affordable big cities. And so rents are quite reasonable compared to, for instance, Boston or the Bay Area, where I have also lived and gone to school. It's way more reasonable, and you can live way better as a PhD student in Pittsburgh on the sorts of stipends that you typically get as a grad student in here than in other places. So rent and sort of going out to dinner and all these kind of things is a lot cheaper in Pittsburgh, and the stipend goes a lot farther. And then finally, just as a general thing, health insurance is covered for free for all PhD students. And this also covers mental health and kind of all the usual things. The health insurance that's offered to students is actually extremely generous. It's really good. It's better than my health insurance as a professor. It's like the most I could pay for it, but it's like the most expensive plan that I would have to pay out of pocket to get is given to the students. It's very good. General life stuff. Here's, again, some examples of cost of living comparisons for Pittsburgh versus San Francisco, New York, Seattle, and Boston. And sort of if you took the stipend, the PhD stipend in RI, which this year is $38,400 a year, if you were to take that and do the cost of living adjustment for San Francisco, New York, Boston, and Seattle, what that would work out to in all those other cities, again, because Pittsburgh has relatively low cost of living, you'd have to get a lot more money in those other cities to kind of have the equivalent cost of living, equivalent standard of living in terms of rent and all these other things. So, and I can tell you the stipends of the schools in those cities are not that high. So you do pretty well here, living wise. And I don't know if the students who actually are living on the stipend want to comment. Michelle or Jaskaran, do you guys?
Yeah, you're absolutely right that it goes pretty far in Pittsburgh. I've felt that, the stipend has been enough for affording me all the experiences and climbing that I want to do. But it definitely depends, like city to city, depending on the city's cost of living.
Okay. And then Rachel's turn. Let's talk about this. Is Rachel here? If not, I can do it. Okay. So I actually gave a risk presentation on Wednesday, so I'm well equipped to talk about this if Rachel's not here. So the RI has a really, really awesome summer program for undergrads called the Robotics Institute Summer Scholars, or RIS. And this is a summer program that takes place in Pittsburgh at CMU, that you apply to. It's competitive. It's open to undergrads. So typically we get sort of not freshmen so much, mostly juniors and seniors, but also sophomores. So you apply into this program. I think it's 10 weeks-ish in the summertime, although it's often gets stretched. So it's basically intended to be your whole summer. You come to Pittsburgh, you come to CMU, you work in a lab alongside PhD students, master students. You're in the lab doing research, and you get a stipend for the summer. So you get paid, so your living expenses are covered and all that good stuff. And basically the intent is to get you into a real research lab, a real robotics lab at CMU, and get some real hands-on experience doing what you would do in grad school alongside PhD students, master students. And it gets you a chance to just see what all that's like. It also gives you a really awesome kind of gateway into the whole grad school application process. The RIS program, in addition to giving you this kind of immersive research experience, also has a whole bunch of networking events and seminars and professional development events throughout the summer. They kind of have weekly events for all the RIS scholars. And this includes a bunch of sessions on writing grad school applications, writing fellowship applications for NSF and that kind of stuff. So it's really fantastic. And they really help you craft a PhD applications if that's what you're into. There's a lot of support for all that kind of stuff. And also, if you're thinking about coming to CMU, it basically gives you the full experience. So you are an informed consumer and know what you're getting yourself into. You get to live in Pittsburgh. You get to hang out at the RI and all that good stuff. And I will say I've had lots of students come through RIS, and I've had a couple who've come in through RIS and then stayed for master's degrees and now stay for PhD. So I have a current PhD student as of this fall who did RIS twice with me, and then came as a master's student and then got an NSF fellowship and decided to stay for a PhD. So it really, you can kind of bootstrap the whole thing if it ends up being, what you want to do. And it's an awesome program. I can't speak highly enough of it. It's great. Okay. I talked a lot, but apparently there are slides about this. Okay, 150 plus offers to top grads programs in the last couple of years, including over 50 to CMU. I had that anecdote of one of my students who's now in the PhD program here who came through RIS. And again, they have a ton of really, really good supportive workshops, application coaching, mentoring for all these kind of things. It's just an awesome program that really sort of coaches you through a lot of different things, and they take good care of everybody. Basically, Rachel, who runs this, is amazing. And it's a fantastic program. What else is there? Okay, and then here's kind of the program dates and the application process for this. So you have to apply into it if you're interested. And again, I highly recommend if you're into doing robotic stuff and you think you might want to go to grad school, you should just apply. It's awesome. And you should kind of keep your eyes open. November 1, the application's open. I don't know the deadline, but you should kind of look at it in November and get an application. All right, and now it's time for Q&A. So, can one of you guys pull up the Google Sheet? My screen is taken over, and I'll be.
Yeah, I can ask some questions from the Google Sheet, and then you all can answer as we go. Does that sound good?
Yep.
Okay, so our first one here is someone asked, how much does poor grades from undergrad affect a PhD or master's admissions? And what if they have kind of better grades in later graduate programs like their master's?
So since I think I'm the one closest to my undergrad right now, I can speak about that. So I had okay grades. I did not have very good grades or very bad grades. But one advice that I got in case I messed up my grades was that your SOP and recommendations are basically free real estate for you to justify who you are as a whole person. So if you do mess up your grades and you can't really do anything about it because you're a senior now, um, you you should talk about your strengths in your SOP, is what I'm saying. That's basically what you have in your hand to make a difference at a later stage.
That's great. Thank you. Next up, I think we've had a couple questions about what to do if you don't think you have 3 strong letters of rec. Maybe you've been out of school for a while, so you're lost touch with some faculty, or you don't have those connections. How can you try, or what should you do there?
Okay, so I would say you could if you worked for long enough with a professor, you can reach out for a research kind of recommendation. But again, if you have been in the industry, there is not really a lot of harm asking an industrial mentor for recommendation. And I think Zach can speak a little to it, how that would affect the application.
Yeah. So as far as letters go, right, these are to convey things that are not in the CV and things that are like more things about your kind of work ethic, like how you are to work with, if you're, you know, a good team player, this kind of stuff. And having your boss supervisor from a job write that is completely normal. In fact, like if you've been working for a few years, like I would expect to have a industrial supervisor write a letter, as opposed to someone who you haven't seen in 3 or 4 years from your undergrad or something. So this is totally reasonable. Like if that's your, situation, you should absolutely have people from work write letters for you. The thing that it won't really convey, right, in that context, like it'll say a lot. And again, it's about getting this kind of reference from somebody you worked closely with. It's not someone who you've, had only superficial interactions with. It should be somebody you worked with closely for like a year or more, who can really say, something meaningful. But also, yeah, like if you're applying to a PhD program and this is really about doing research, and you've been in industry in a not researchy role for a bunch of years, that's a situation where, again, you won't necessarily have any research experience, and you won't have a supervisor who can speak to your research experience. So that's a situation where you might want to think about master's programs as opposed to PhD programs. And like you can apply to all kinds of stuff. It doesn't hurt to apply, but you'd probably be more likely to get into an MS program where you can kind of, again, use it as a stepping stone to bootstrap your way into a PhD application after a couple of years. And that would give you a chance to, again, establish some research experience and have letters from people who can speak to, again, research stuff that you've done.
Great. Thank you so much. So another one that we've got a reasonable amount, maybe Michelle, you want to take this. Do you need a publication to get into a master's or a PhD program? How should you go about navigating that?
Right. So generally, people applying to or getting into PhD programs have a relatively decent amount of research experience, whether that's working in a lab, like an undergrad, or maybe a research lab in industry. And often a byproduct of, having that research experience is having something like a conference paper. And so I think it's not a formal requirement, but it may be a correlation between students who are getting into PhD programs.
I guess I can maybe offer some other side of this, having been on admissions committees in the last couple of years. It's definitely not a requirement, and we definitely admit plenty of people who do not have any publications. But yeah, kind of as Michelle was saying, it's almost like a byproduct of if you're doing lots of research, you're gonna get on papers, and I would say as kind of a byproduct of having a huge application pool and being a top department, like a huge fraction of the students we admit do have conference papers coming in from undergrad. So it's not, again, it's definitely not a requirement, but like, I don't know, just as a guesstimate, so maybe order half of our students or more like have conference papers coming in the door. But yeah, definitely not a hard requirement. And there's lots of ways to show that you have these kind of skills. So it could be that you've, again, worked in a lab with a professor and, for a year and a half or something as an undergrad and got a good letter. Other things though that carry weight that are also really great. We've had applicants who, for example, like gotten really into robotics competitions and done awesome things there. We've also had applicants who are just really, really awesome builders and makers who are very mechanical, who like have awesome project portfolios, and they've like built lots of robots and, kind of less in a formal setting, but they have like a lot. We've seen, statements with photos of this kind of stuff or links to like personal portfolio websites and CVs where people have like videos of crazy things they've built. Like there's a lot of ways to show off, that you've done some things, and it doesn't just have to be the classical research lab at a university. It can also be, I think someone also asked about, startup experience. If you've like been involved in a startup and built something from the ground up, gotten, I don't know, some full stack robotics experience, fielding something, that's also excellent, right? If that's at a company, that's awesome. If that's in a research lab, that's awesome. There's lots of ways to kind of, show off that experience, and it can be in lots of different ways. It does not have to be a publication at ICRA or whatever. It'd be a lot of different things, but you definitely want to like find a way to convey that in the CV, in the statement, et cetera, right?
I'd like to add one small point to that. So like you mentioned, there are students who do competitions and are good at like doing these kind of projects in not a formal setting. So I did some research in my undergrad, but which did not like translate to a publication or like big publications. But it indeed does help if you shape your profile around the stuff that you enjoy and that you actually did. So even though I did a lot of research, I really, really enjoyed doing like competitions. And the only publication, and I believe a good publication that I had, was a report of one of those competitions, and it also got accepted. So it's good even if you don't have a very core research-based publication. If you did very good competitions, and if you have a report, if you have a slide deck for it, just link it. And I think, at least I hope so, that it accounts for the work that you've done.
Yeah, you want to show off, right? Like if you've done something cool, like find a way to show it off in the application, right? Like, and it doesn't have to be a classic, academic paper kind of thing. It can be a kind of anything.
Something I've done in discussing my industry experiences in the SOP has been discussing the approaches I took to kind of solving challenging problems and sort of my thought processes and how that kind of translates into skills that you can use towards research and solving open problems in research as well. So you can definitely talk about like how your skills from working on those previous problems translate, even if it's not like specifically a research problem.
Thank you all. We've got a couple questions now on how should people talk about kind of research experience from other departments or other fields, or if they have an undergrad degree that's maybe not necessarily in robotics or mech-y or EE, can they still kind of apply to the PhD program or the master's program with that?
Definitely, 100%. Yeah, I mean, because, robotics is super interdisciplinary, and because there are very few actual dedicated robotics departments, the huge majority of our applicants are not coming in with formal, robotics degrees. And it ranges, it's mostly engineering, right? So it's mostly computer science, mechanical and electrical engineering, actually aerospace as well. My background's in aerospace, actually. My degrees are in physics and aerospace. I didn't do robotics until later on. So this is very normal and standard. And I think, we are looking for people who have technical skills. So like what the title of the degree, doesn't matter at all. It could be physics, could be, but, you need to have technical skills. So it's got to be something where you've learned how to do math and, whatever. You need to have those skills. But yeah, in principle, your undergrad degree could be in, anything from like computer science, math, physics, EE, ME, aero, like any of these things, right? this is all fine. And I don't think there's a huge amount of prejudice based on that at all. The one thing that I kind of mentioned before is if you're making a really hard pivot between two areas, like if you worked in a really different area, if your undergrad degree is in, say, math, and you've never like, touched hardware or like, touched a robot or whatever, you might not be super strong candidate for a PhD program, right? Because you're going to be competing against people who have these kind of experiences, who've done, hands-on field robotics maybe and stuff like that. If you have a math degree and you've done like, I don't know, FIRST Robotics or like, whatever, if you've done like robotics competitions or like been involved in robots and your degree's in math, all good. That's fine, right? But if you don't have your degree's in something sort of else and you don't have like any other related experience, then it might be hard, right? And so in that situation, if you don't have super aligned experience, that's where applying to master's programs is good. They're easier to get into, and that'll give you the opportunity to gain the experience and get letters and all that kind of good stuff, and then you'll be competitive for a PhD.
And I think I can attest to that firsthand. Like so many majors that Zach mentioned, and even though I'm from a mechy department background, I majored in manufacturing. But the competitions and the projects and everything that you do along the way, I think that speaks more about you as a candidate than your formal what's written on your degree.
Yeah, I don't think the department matters at all. That's basically the short answer.
Okay, we're almost out of time, but we have a couple more questions, so we're going to do a lightning round and quick answers to these questions, and then we'll hopefully be able to get to everyone's stuff, and we'll wrap up. So real quick, Zach, can you talk about, we have actually 3 different master's programs. Can you talk about them really quick?
Probably not, unfortunately.
Oh, okay.
So there's MSR, which is like the researchy one, which is much more, again, the research masters, and then there's professional ones. That are, so that the research versus
I think since I remember the names, I can probably go over it very
MSc quick for computer vision, and MRSD, which is robotic system development. Those are both professional programs, and then the MSR is the research program. That's basically it.
Exactly.
Okay, great. Someone asked, can master students get TA positions?
Possible, but unlikely, I would say.
Okay.
For a simple reason that we tend to want TAs who've taken the class and done well in the class. That's usually the bar. And as a master's student, you're only around for 2 years. And so like maybe if you took the class the first year, you could TA the second year, but you're less likely to get that position because there's PhD students around with more experience who are required to
TA. Okay, next one. Does having kind of incremental work that's published in maybe a less prestigious journal affect your application? Is it bad to publish in quote unquote less prestigious journals?
If you're an undergrad and you have any publications, this is good. You should just put it in there. It's not going to be as good if it is a top tier conference or whatever, but it doesn't hurt.
Nice. Someone asked very quickly, if they are planning to begin a master's in fall 2024, are they still eligible for RIS?
Yeah.
Very good. There was one more that I couldn't find. Maybe that is all of them.
Amazing.
Yeah. Okay. Oh, actually, sorry. One last quick thing. Some people asked, like, how early should you contact faculty? Does it matter? I know, Zach, you talked a little bit about this before.
Yeah, it definitely matters. If you can get, basically you want to have like, be able to connect a face to a name. Like if people know who you are, it's good. And I think typically I start like kind of recruiting and talking to people in a serious way, like the summer before. Like I talk to people like this summer, for instance. I talked to a lot of people who are like, applying this year. Maybe the spring before, but usually really the summer before is when it like really starts to get serious, and into the fall or whatever. Just before the applications are due. But yeah, I think summer before, at the summer conferences, that's usually when a lot of this kind of happens.
And then quick follow-up to that, is there a way to know which faculty are taking students this year?
Yeah, this is kind of tough. I actually, this is the thing I get the most emails about. is like, are you hiring next fall? And unfortunately, it's really, really hard for me to forecast this because like I'm writing proposals all the time, and it's really dependent on which grants hit and get funded. So I'll have positions for certain projects that are funded, blah, blah, blah. But often I won't know until, you know, closer to I won't hear back on a lot of these things, right, until later on. So it's a pretty stochastic thing, and it's actually surprisingly hard for me to forecast it. It's somewhere between like 0 and 2, right, for next fall. And I kind of will tell people that in the email. It's like, I'll probably take 1, but it might be 2 and it might be 0. And I can't really say for sure for like several more months, you know. Like I'll go, you know, I won't make this call until sometime over the summer when I'll like look at my finances for the next year and what grants I've gotten and stuff like that. So yeah, it is tough. I realize that puts you guys in an annoying position, and the applications are not cheap and all that stuff. But yeah, it's unfortunately like it's a pretty stochastic process on our end as well. Like we have to pay you guys, and I don't know what grants I'm going to have in, you know, in August or whatever right now.
All right, and very, very last one before we wrap up and thank our speakers. Can you transfer if you are already in a PhD program and your circumstances have changed, you'd like to leave and join RI's PhD program or another one? Is that possible?
It is definitely possible, though, you know, calling it transferring is maybe not the right word. Like you're basically starting from scratch when you move, because of the way PhDs work, right? You're kind of like getting into a research area in a lab, and you have to write a dissertation that's kind of coherent on a single topic. So I think it's pretty hard to transfer and like stay on track at the same point you were. Like if you're a year or 2 in and it really isn't working out and you want to move, you can certainly do that, but you'd be applying in kind of more or less from scratch. And unless you're finding someone else who works in an extremely related area in this new place who's interested in the same research direction, which again, I think is unlikely, you're probably looking at kind of like starting in a slightly different research direction, more or less from scratch. Like you're going to lose time and almost restart most likely. Again, there's exceptions to every rule, but it's definitely possible, but it's not like you're going to start from where you left off necessarily.
Okay, unfortunately, we're out of time. Thank you, everyone, for coming. A huge thank you to our panelists for talking today and taking the time. All of these, the recording and the slides will be uploaded to our website, when you can go there to check out more resources for graduate application. Good luck, everyone.